Okay, guys. I know you guys are probably frustrated and like, why the hell hasn't he done the answers? But I've had an epically shit day, which ended with my binder that I bind my books for my students with getting jammed and frickin' dying. So now I'm trying to find a binder because I need it by like 3 days ago. Anyway, enough of my shit. I've heard this is like ridiculously hard. I'm just going to smash it out. Hopefully, I mean, you probably don't even care how to do them. You just want to know what the answers are. Okay, the amplitude and period of that function. Well, you can never have a negative amplitude, so scrap those. It's a half, so it's one of those two. And my period is always 2 pi on the coefficient of x, which in this case, where's my rubber? Far out. It's just been one of those freaking days. Okay, so 2, bloody hell, 2, 2 pi on 3. Oh, why did I even write that? It's just that, e. Okay, the parabola equation that A, B, C are real, of course, they are. It's methods. The equation of the axis of symmetry, x is negative b on 2a, but b is 2b, so negative 2b on 2a, they cancel, and negative b on a, it is a. I'll find it first. Okay, two functions p and q are continuous over their domains, which are negative 2 to 3, negative 1 to 5, negative 2 to 3 with an open circle, negative 1 to 5. So the crossover domain is going to be negative 1 to 3 because they only exist where the functions themselves exist. Okay. Consider the system of equations. Let's get them in the form y equals mx plus c. So y is k on 5x plus k plus 5 on 5. Y is negative 4 on k plus 1x plus 0. Okay, their gradients are the same. So k on negative k on 5. Negative k on 5 is equal to negative 4 on k plus 1. 4 on k plus 1, I'll just get rid of the negatives. Cross multiply, k squared plus k is equal to 20. K squared plus k minus 20 is 0. K plus 5, k minus 4. So k is negative 5 or 4. I should have just looked at those and found that. Okay, negative 5, I put it into that, I'm going to get 0, and that's going to be 0, so that's right. If I put 4, I'm going to get 9 and 5 and 0, so the only answer is k is negative 5, because I've got to have the same gradient and y-intercept. Okay, which of the following functions has a horizontal tangent at 0, 0? So x to the negative 1/3 looks like that, x to the 1/3 looks like that. X to the 2 on 3 is just going to be the right-hand side of that, so they're all vertical. X to the 4 on 3 is going to go like that and like that, so it's going to be that. We can test it. X to the power of 4 on 3. Analysis sketch tangent at 0, 0. It is 0. So no, that's the right answer. Okay, from 3 to 10 is C, from 7 to 10 is D, 7 to 3. So 3 to 10 plus 7 to 10, actually we need that to be 10 to 7 because they basically cancel each other out. That one's flipped, so it'll be C minus D, i.e. negative. But we want to go from 7 to 3, so we've got to change this to be negative. So it'll be negative C minus D, which is D minus C. Okay, here, log E of x, x is greater than 0. root 1 minus x, x is less than 1. So, what was that? Log e, and then root 1 minus x. And there's our function. So our derivative is going to exist for everything up to 1, but we can test it. How do you undo? Stupid thing. So d dx of that sucker. Okay, that red bit can't exist. It can only be so it's got to be up to 1, but it won't include 1 because at an endpoint the derivative doesn't exist and there's an asymptote there. Okay, our box contains n green balls and m red balls. A ball is selected at random, its color is noted, the ball is then replaced in the box. So it's replaced, so it's going to be binomial. 8 selection, so n is 8. What is the probability green ball is selected at least once? So the probability that x is greater than or equal to 1 is 1 minus the probability that x equals 0. So 1 minus 8, choose none of them are green. A green ball is n over m plus n, and that's going to be to the power of 0. And a red ball is m over m plus n, and that's going to be to the power of 8. That's 1. That's 1. So we get 1 minus m on m plus n to the power of 8. B. Okay, sorry, my phone's been going off. Okay, a function is given by that. Tan of a value of a for which it's continuous and smooth at 2 pi. So let's just do it graphically. Tan x on 2 sine of ax. So let's just say x. Now, we want to look at 2 pi. So, 2 pi is that point there, because that's just a normal sine graph. So obviously, when it's 1, they don't have the same gradient, because it says it's got to be smooth. Okay, there's no reason to use 1 anyway. So let's try 2. Nope. Obviously, negative 2 is not going to work if 2 doesn't. Let's try a half. Negative a half may work. Sine negative x on 2. Okay, so you can see that is smooth. They're going to join up smoothly. That's our only option. So negative a half. Okay, continuous random variable is this. The value of k such that x is less than k is 0.35. So we can't just assume it's going to be in there. If we went from 1 to 6, let's go 1 to 6. Is it x minus 1 on 20 dx? 0.625, yep. So that's greater than 0.35. So then we say go from that to maybe z. Let it equal 0.35. Solve for z. Okay, it can't be that value. It's got to be that value, but we want it exact. So it's root 14 plus 1. Okay, two functions f and g, continuous differentiables. F of negative 2 is that, f g of negative 2 is that, f dash of negative 2 is 3, g dash of negative 2 is 2. The gradient of that graph. So how do we derive that function? We know dy dx. Leave that alone. derive the second one, leave the second one alone and derive the first one. And we want it at -2. -2, -2, -2, -2. So f of x times g dash of x, -14. That times that is plus 24. Add them together, we get 10. Okay, probability of mass function, discrete random variable is shown below. The maximum possible value for the mean of x is, okay, k squared minus k squared, that's 0, 3kk. Okay, that's just going to be 1, no matter what. So no matter the value of k, this is always going to equal 1. However, k can't be negative because you can't have negative probabilities. So let's find the mean. Multiply those together, -k squared, 0 plus k minus 2k squared, minus 8k plus 2. -3k squared minus 7k plus 2, -3x squared minus 7x plus, what was it? 2. Find the maximum of this sucker between 0 and infinity, you stupid thing. Okay, max value is 2 when x equals 0. So if k was 0, they would all equal 0, but this would equal 1, and the mean would actually be 2. Okay, the following algorithm is Newton's method for loop for 3 iterations. The return value of the function Newton. Okay, so there's our function f of x, matches up with that. Derivative, so when we derive that sucker, we get that one. And then that's our initial value. So we know x naught is 1, and f of x is x cubed plus 3x minus 3. 3 iterations. So we can sort of just cheat and use, well, I guess it's not cheating, x cubed plus 3x minus 3. Define it. We know Newton's method is x minus f of x over, fuck, copy you stupid thing, d dx of f of x. And our initial value is x is equal to 1. Our second value, we use our previous answer, and then we do the same thing again. So you just hit enter. However, we want them all in decimal. So our first answer, second answer, third answer, 0.81773. C. Okay, a polynomial has the equation that the number of tangents that pass through the positive x-intercept. So that's a negative, negative 0. So the positive x-intercept is 1/3. We can find the equation of the tangent at any point. So x was at 3x minus 1, x plus 3, x plus 1. Let's find the equation of the tangent at the point z. Now, we know that tangent has to pass through y is 0 when x equals 1/3, because that's going to be the y-intercept of that thing. Okay, and then if we solve that for z, oh, you stupid thing. We get 1, I'm not sure if I make it exact. We get 1, 2, 3 solutions. So at those 3 points, the tangent's going to pass through that. Let x be a random variable with a mean of 100 and a standard deviation of 20. Let y be a random variable with a mean of 80 and a standard deviation of 10. So let's say 80 is there, 100. Standard deviation of 10 means it's going to go higher. 20 means it's going to go wider. So it's going to look like that. Which of the diagrams represents the best? Okay, so which one? Oh, there it is. X and Y. So X is the one with the higher mean. So that's it there. And because our standard deviation for this one is lower, it means it's going to squish up more. So it's got to be A. Okay. Given that the product function f times g of x is equal to that, the rule for the function g is. So we just divide that to the other side. So g of x is e to the x minus 1 squared on e to the x minus 1. Now we subtract our powers. So x minus 1 squared minus x minus 1. Simplify. X minus 2, x minus 1. B. Okay, the height of a cylinder and the radius is formed in a thin rectangular sheet of metal, length x and width y, by cutting along the dashed lines below the volume of the cylinder. So we know the volume is pi r squared h. We know that plus that plus that. Now if that's r, that's also r, that's r, that's r, that's r. So h plus 4r has to equal x. And that length there is equivalent to the radius of that. So 2 pi r is equal to y. Okay. H is equal to x minus 4r. R is equal to y on 2 pi. So here that's equal to x minus y on 2 pi times 4. So 2y on pi. V is equal to pi r squared, y squared on 4 pi squared, times h, x minus 2y on pi. Okay, that cancels with that. When we multiply that in, we get pi xy squared on 4 pi minus 2y cubed on 4 pi squared. If I make that squared, I've got to add a pi to the front. Is that an answer? 4 pi squared. Pi xy squared. Yep, so it's B. Okay, consider the functions this, sine ax, where a is positive. The number of local maxima and minima is always equal to. Okay, so the easiest thing is just going to be to sketch it. So sine x between negative pi and pi, well, we know that's just going to have one minimum. If I say 2, and we go between negative 2 pi and 2 pi, we get 1, 2, 3, 4. So when a is 1, we get 1. When a is 2, we get 4. So it could be that or that. That tells us we've got to try 3. And it's got to be between negative 3 pi and 3 pi. 1, 2, 3, 4, 5, 6, 7, 8, 9. Where'd it go? So a equals 3 gives 9. So it's squared. Okay, find all values of k such that it has two real solutions for x, one positive and one negative. So I think the best thing to do would just sketch it and graph it dynamically. What was it? 4k plus 3x plus 4k plus 3x, get rid of that z, and then plus, what was it? 4k squared minus 9 and 4. 4 squared minus 9. Now the good thing here is that we know the values that we care about. 3 on 4, negative 3 on 4, etc. So 3 on 4 gives none. So 1 doesn't give us two positive x-intercepts. If we get to 0.7, we can say we've got a positive intercept and a negative. So 0.7, we've got them between 0.7, still going. Okay, negative 0.75 and 0.75. Because I knew it couldn't be 0.7, it's got to be something else, and we knew that was 3/4. Okay, here, f of x is log e x plus 1 on root 2. So let's say domain, range. All right, we know f has a domain. It can't equal negative 1 on root 2 because that'll make it equal 0 to infinity, and it's got a range of all reals because it's a log graph. Sine x has a domain of negative infinity to 5, but it's going to have a range of negative 1 to 1. So we know this function here, for that to fit into there, that's got to be less than 5. So log e of x, log e of x plus 1 on root 2. If I let that equal 5, we would get e to the 5 minus 1 on root 2. That's what x is. So that would be my upper bound here, e to the 5 minus 1 on root 2. This one here, for that to fit into there, we know that negative 1 doesn't fit into there. So we know sine x has to be greater than or equal to negative 1. Sorry. This has to be greater than or equal to negative 1 on root 2. If we solve that, we get x has to be greater than or equal to, or greater than, it can't be equal to, because it can't be equal to, negative pi on 4. Okay, so here, that's where our negative pi on 4 and our pi on 4 values come from. Our upper value, the largest value of that, we know our largest value of this. If our lower value is negative pi on 4 here, then our upper value, if that's going to equal we know that is going to be that function there. Basically what we need to do is work out which one of these is closer to the origin. So if I have negative 1 on root 2, there's my root 2, we get that negative pi on 4 So our domain's got to be the smaller of the two. So it's got to be -1 on root 2. So we can scrap those. And we know we can't include -1 on root 2 because that's a round bracket because we can't log 0. So our answer has to be A. That one's a bit nasty. But you had to work out which one of these is larger because we know the values of x for which they both work, they both have to exist. So it has to be the one that's closest to the origin, i.e. More to the right. All right, hopefully I'll get a chance to have a crack at part 2 sometime soon. Hope you did okay. All the best. Bye.